So, we saw how to make a 3D A-star. Now let's put it to the test. This is going to be a series about making a turn-based game. But this video is going to basically be how we move around a unit based on a new Pathfinder and all that. Okay, now I'm going to do two series of this. One will be making a more simpler turn-based game like XCOM, and the other the new XCOMs, and the other will be a little bit later with something else. Okay, something more advanced. Now, basically what we're going to see in this video is visualize our path. Okay, and then if I click, I can set the path for my unit to move, and I can also avoid obstacles and objects. And there is also two-floor movement, like you see over here, but right now it's not ready for two-floor movement. We will see why. Okay, and when I hit space, my unit moves around and it behaves like that. Now you notice that the movement is kinda linear, and that's exactly what I was going for, since it's a lot based on the new. It's basically based on the new XCOM movement. Okay, and if you want to move on the second floor, you see that it lerps like that. Okay, this is not ready yet because there's some other factors to move to make it look good to move like that. Okay, and this isn't ideal either. And the other thing we're going to do is to actually have some form of level readability. And what I mean by that is to actually know that this is an obstacle. Okay, this is an obstacle, this is, he can walk over here. Okay, and all that, because later on we're going to see how when we are moving, when we are near a wall, how we can take cover behind the wall and all that, to be affected by our stats when there is combat and all that. Okay, and you see now for right now we're only going to focus about reading obstacles and not creating what I just said with the cover and all that. Okay, you will see that red means we cannot move on that node. Okay, and the slight gray transparent material is that we can move on that node. Now let's see what we're going to need with we have the grid and the Pathfinder, which we saw on the pathfinding videos. Okay, and we need basically some other scripts we're going to see, and the unit control. So let's start, because we have a lot of stuff to manage. Now I'm going to use a level manager, and I'm basically going to need the level initializer over here, and because I want things to be created basically to be created not all together, but handle what prefabs it creates, you know. So we want to have this script first, because we need to create the grid first, read the level, check what is workable and what is not, and then create your units and place them accordingly. So let's start with the level initializer. Of course, you're gonna need the scripts from the Pathfinder, and you can find them in the links below. So we have, keep in mind of the namespaces. Okay, we're going to use a lot of them in the future and right now, so that we can be more organized and we can move projects around and scripts around without having to change a lot of stuff. let's see with the level initializer. Okay, of course, a mono behavior project. We basically need a prefab for our grid and a prefab for our units, and right now we're simply only going to focus about making units. We simply only want one unit, but later on we want some more. Okay, and then we just initialize a wait for end of frame, and the grid stats is basically because we are updating the grid, we are creating the grid. Okay, and I do not want to have a lot of different prefabs for each kind of grid we're going to use, so I let the grid stats handle it, and I'm managing it from basically from the level initializer. Now on start, we initialize the wait for end of frame, and we start the coroutine which says init level. Now what this coroutine does is simply call the other coroutines we need, which is the create grid, okay, which is simply instantiates a grid. We do not care about we kinda care about basically the position, and we simply assign the initialized grid. We simply we initialize the grid by passing the grid stats. Okay, instead of passing the max x, max y, and all this stuff and everything else we want to add over here, we can simply pass the whole class, and then it updates from there. And then when we return, when this coroutine ends, it's going to yield return, and it's going to come over here and then call the next coroutine, which is create units. So we have our grid, we want to create the units. Because the unit needs to listen to the grid, we cannot have them both created on the same thread, on the same time. Okay, because we're going to get an error that there is no grid. So we simply create how many units counts. We simply create a new unit. Now of course all of them were going to be instantiated on the same place right now, and we do not want that, so we're only going to basically create only one unit. Okay, the coroutine ends, comes over here, and then calls the enable player interactions. Since we have a grid, we have a unit, that means we can actually start moving around. Okay, we can enable user interaction, and that is the level initializer. Let's see the changes we did on the grid base. Okay, we have everything I am not explaining over here. We saw that on the previous on the pathfinding videos. Now we need to have a list of Y collisions. Since this is pathfinding, okay, if we have more than one floor, we cannot use just the collider that is for the base floor. We need to use a collider that is on the top floor too. But because we do not have a floor, we do not cover the whole second floor with the same, okay, we basically we can only move over here, so we cannot use all the time this collider, and later on we will see something different for this. For right now I'm simply disabling this collider for the second floor, and I simply have colliders on this. I think this was somewhere. Yeah, anyway, there are some colliders over here, and I don't remember the exact game object right now, but that's how basically I find the colliders. Anyway, let's move on. So we need a list to basically store the colliders for each floor. Okay, we need a reference to the level manager, which we're going to see a bit later, and instead of creating the the grid on start, I'm creating the grid on a public function, which is the public function is the one I'm calling inside my level initializer. Okay, init grid. So that's basically, instead of using the start, because the start is we basically want to make sure that the grid is created on the correct order, basically. Okay, and we pass the grid stats, we update the variables we have over here with whatever we have on the grid stats. Okay, and then we get the instance for the level manager, which is simply, the level manager is really simple. It only has one it only has one list of level objects. We basically how many basically takes all the objects in one floor, and then it adds them on the correct list. So if you want to move between two floors, you can disable the objects on the top floor and so on. Okay, and it's also a singleton. Okay, so that is the level manager. Keep in mind of the namespaces. And then we create the grid as we saw on the previous on the pathfinding video. We create mouse collision, we're going to see over here. We close all mouse collision, we're going to see all of that. And we basically just enable the first mouse collision. Now, on update, everything we have over here, we're not even using them anymore, so I can simply comment them out. Okay, this was just for test for the pathfinding video. And we're basically not even using this one anymore, so but I'll keep it over here. Now, what we're going to also add is this function, which is to take a node from a wall position. So I can pass a raycast or everything else I want to take. Okay, I can return the position, the node basically from the wall position, exactly as I said. Now we simply need to break it apart into floats. Okay, so we have different x, y, and z. We need to subdivide with the offset we have on the grid, and then we simply round to int for every case. But we also need to check if the x we just rounded is greater than the maximum x minus 1, and if it is, then assign it as the maximum x minus 1, and basically the same for the y, the z, and so on. And we also need to check if it's lower than 0, then make it 0, and we return that node. This is not really needed anymore unless we want to hardcode stuff, but we're going to keep it. And this is the create grid, which basically is the same, but after we initialize the grid, we basically need to create on the level manager, we need to create entries for our list. So we check how many on the y we have added, and we use the y because we have basically the y is how many floors we have. Okay, so we check the y, and if we have if it has just one, okay, it's going to add only one. Otherwise, and we also pass the floor index, and we do it this way because we can basically change that, because we might want to start from 0 level but go negative level. Okay, if you want to have basement, or if you want to have something like voxel level and all stuff like that, or even pretty much if you want to have dynamic levels like Minecraft, for example, you can do that. So, but the level manager is basically so that we can move, so that we can disable and enable objects depending on what floor we are looking at. Okay, if you want, you might not even need to disable the game object, but fade them out. Okay, all that stuff. You can do whatever you want over there, basically. So we have this from the previous video. We saw all that. The only thing that we're changing over here is we need to create a new script, which is the node references. And the node references is basically the tile renderer. Keep in mind the namespace, which basically is the tile renderer. You see, if I click play, you will see that on each node. Okay, each node now has a script that derives from mono behavior, so it can be a game object too. And right now we're only going to keep that the tile renderer, which is the MS renderer for the tile, and we simply have two materials. If it's walkable, it's a slight gray like this, and it's pretty transparent. Okay, and if it's not, then it's like this, it's red like this. Now we need to assign this on the prefab, and if I didn't mention what the floor prefab is it's just a quad inside an empty game object, because we want to rotate it to 90 degrees. Okay, and floor prefab has only the node references, the quad renderer, and the two prefabs. And we started as unwalkable, so we started as this transparent red. Okay, make it a prefab, delete it, and drop it on your grid prefab, on the floor prefab. So we take the component node reference. We use get component in children because we might make a mistake, or we might change something later, and take the node reference, use it on a different game object rather than the game object that has the node. Okay, so if we use get component in children, then we can take it wherever the node reference is. We start with all the tiles unwalkable. Okay, and then we say if they are unwalkable, we basically disable the renderer for the tile. Now we saw the raycast hit and boxcast all of the previous video, but I did some changes. First of all, we need to change the vector 3 from 0 or forward to up, and since this is the extents, that means basically that we're going to have a cube that is of the length of 1 by 1 by 1. Okay, and then we check all our hits that our box cast all returns, and now we need to find basically what we found. We have a new component, which is the level object, and let's see the definition for the level object. Always keep in mind the namespaces from now on. Okay, and for right now the only thing that it has is a simple enum, which is floor, obstacle, and wall, which we are not really using anymore. So the only thing we're going to use right now is the floor and the obstacle. If it's a floor, we can move. If it's an obstacle, the node is unwalkable. So we check. We first need to we store the level object to so we're not calling all the time the level object. We first need to add it on the level manager level object on the floor we are currently at, but only if we haven't already added it. Next, since there is a level object, that means we want to enable the tile renderer. Okay, that is basically for our visualization, and on your end game you probably won't need this. And then we simply need to check we have to check first if the level object is an obstacle. Okay, because a lot of nodes, basically every node that has an obstacle, it probably already has a node that is floor. Okay, so if there is an obstacle, then the floor will probably just override that. So we check if there is an obstacle, we make it unwalkable, we change the tile material to 1 so it gets that red transparent material, and then we simply break the loop. And then we continue. If it's not an obstacle, then we check if it's a floor. So, on the end, we simply pass the node after we basically updated all its variables. Now, this is pretty bare bones level readability. Okay, on a later part we're going to actually add a lot more on this stuff for over here. This is basically for just this video mostly. Okay, we're gonna keep some of the stuff, we're gonna change them later, and later on, as I said, we're going to check what kind of node, what kind of level object is. So if a node has a wall from one side, then we disable the pathfinding from that side and stuff like that basically. But we're going to see that a bit later. So we have our grid. Let's create. We need our mouse collisions based on every floor we have. Okay, so we create a new game object. We change the transform name and we pass the floor so that we know what we're changing. Okay, we are adding a new box collider and we change the side to be the offset of the X. We do not care that it's be too tall. Okay, so it's better to have something like a small value, and the Z will also multiplied by the offset Z. Then we need to place it correctly. Okay, and that we do that by taking the whole length of the X and the Z basically. Okay, we subdivide that by 2, so that means we have the middle point, but we also need to subtract half of the offset X. Okay, for the Y we only need to multiply it by the offset, and for the Z the same as the X, and then we add on the Y collision on our list with all the collisions. We need to close all mouse collisions so they are not starting, and the grid base is also a singleton as we saw on the previous video. Okay, so it runs all this and it comes over here and enables the collision for the mouse collision on the first level, and that is how we create the grid. Now the next on our list is it creates the units. Let me find the level initializer. Okay, creates units, a for loop, we saw that, enable player interactions. Let's see the player interactions. So, keep in mind that we need all this: grid master, pathfinding, and unit control, all the namespaces, and we're also going to include the PI stands for player interactions. All script that has to do with how the player or the input of the player is, we basically going to call it player interactions. Now we need to have which is the active unit. Right now we're only drag and dropping it. Later on we'll see how we're going to change that. We need to know if we have a path and if we want to hold the path we already have. Okay, references to Pathfinder, the grid base, and a place to store the previous node. if we want to visualize the path, a prefab that has a line renderer basically, and the line renderer that we are using to visualize the path. On start we get the singleton for the grid and the Pathfinder, and then on update we can check if we have an active unit. Okay, so that's not null, we have assigned a unit, and if we do not have a path, we need to find the starting node, which is node from wall position. Okay, we pass the active unit position, that is always our starting node. So, target node, we need to find the node from mouse position, and we come over here. Okay, we need to return a node, so we have a return value over here. We start as null, and if our camera hits something with a collider, okay, we do array from the camera on the mouse position, and if we hit something, then we have a return value, return the node from wall position. Okay, and then it returns that. Now we have a starting node and we have a target node. Now we have to check if the target node is not null and the start node is not null. Okay, just to avoid errors. The target node is mostly, in most cases, it's probably the one that is going to be null. Okay, because if there is an obstacle, then we're not taking target node is null, so there is no path to create. So we have start node, target node. Then we need to check if the target node is not the previous node that we stored. Okay, so if we already find one path, there's no need to keep redoing the path every time for how many frames the mouse is going to be over it. Okay, and if we're not holding the path, so that means the player has not clicked for that path. Okay, then go to the Pathfinder, and as we did before on the Pathfind videos, we request a pathfind. We pass the starting node, the target node, and we pass for the delegate, we pass the function we're going to use, we want to need to use basically, and we need to use, and that is populate path of active unit. We store the previous node and hash path returns true. Now populate path on active unit. Okay, this takes a list of nodes. The active unit is what we use on our units, and basically unit controller. Let's see the definition. Okay, basically we're going to see it in a bit, a lot more. Okay, namespace unit control. We basically populate these two lists. So keep it on that, and let's go back to player interactions, and we'll see in a bit all this. Okay, populate path of active unit. We clear the previous path we had. The short path is the same. The active unit has the same path, but we basically, we make it more simpler. So if we have a straight line, if we want to move a straight line, we do not want to lerp between each point. We only have to lerp between the first point and the last point we want to have. Okay, and we basically simplify the paths by checking if the next node is on a different direction than the previous node, and all that. We'll see it in a bit later. Okay, we basically just what you need to take on over here is basically we clear the current path and the short path. We add the position of the active unit on the current path. Okay, the starting position, because the list we take from the Pathfinder does not include the starting position. And then we check for how many nodes we have on our list, and then we keep adding them on the current path. we call two functions that we're going to see on the unit control, which is the evaluate path, which creates the sort path list, and the reset moving variable so that we can move the next time we click, and then we close the hash path. So what this does is the hash path basically waits for the thread to finish. Okay, so hash path, it will not create a new path, so it will not come in here until the delegate is called, so it has finished calculating the path and makes the hash path false. Okay, so we're not basically opening up threads like crazy. So if the player clicks, it holds the path. If it clicks again, then it stops holding the path, so it creates a new path finding if all the if statements are true. Okay, that is pretty bare bones right now, okay, but it works for what we need in this video. Now, if the active unit sort path count is lower than 1, so that means it's 0, then we're not holding the path anymore. If we want to visualize the path, we have, and the line is null, so we have not stored a line renderer. We simply instantiate a game object. We do not care where it is, where it instantiates. We only need to take the line renderer, and the prefab we instantiate over here is an empty game object basically that has a line renderer. So we need to set the vertex count for the line renderer, and that is how many points the sort path has. And then for each point we simply say that the position we want to set for the eye is the world object of that node, the transform.position. So that is what we have for the player interactions. Find node from all position. We saw that. Populate path of active unit. We saw that. It's what we call on the delegate, and we are complete with the player interactions. Okay, as you might have guessed, we're going to expand a lot more on this later. Let's continue. Let's see what we need to have on our units. We of course need to have it, a prefab, and we have the unit over here. So we have the animator, unit controller, unit states, handle animation, and arcade handler. The animator is very simple. You'll find these animations and are basically the animations we used on the third person shooter. We're basically only going to focus on the locomotion, which has two states, idle and run. Okay, and we learn between them with the float, the parameter called movement. And we're going to expand a lot more later, so I'm not really going to bother with this anymore. So let's see the unit states. Unit states we're going to expand a lot more, and as far as units are concerned, we're going to expand a lot more later. Now we need to have some variables over here, but basically what we only are using is the maximum speed, the moving speed, and the hash path. I think we're going to see later. Let's see the unit controller, which is this. So we have the unit states that we saw what it is, our grid, our starting position. It's hard coded to when we want to start, the current node we are, if we want to move on the path, the index on our path, okay, current path, short path, we talk about that. The speed is how fast we move. Start time, and I think we're not using even this one, we're using the one on the unit stats. Start time, fracture length, start position, target position, and update position. All this stuff are for lerping between the nodes on our path. On start, we initialize. Okay, we get the grid, we get the unit states, place on node immediate, takes the node position, vector 3 anyway, okay, makes it seal it to int, xyz, and then we have finds the node from the grid, and then it places the transfer position directly on that node. And we only use that for initialization, or if you want to teleport around, you can use that too. The current node, we find the current node by using our starting position, okay, and we place it on the current node. We initialize the current node. So we have, okay, this is for right now, and only for right now. If we hit space, move the path to true. The states from the unit states, the state move from the unit states is controlled by if we are moving on the path or not. And if we are moving on the path, if we haven't updated the positions, we need to check if the index of our path is lower than the short path.count -1, always -1. Okay, we start adding on the index. Else, we have finished finished moving from all points into our current list of path, list of nodes. We need to find the current node. Okay, just to be sure, we reinitialize this. The starting position will be the current node world object world position. The target position will be from the short path list, the index of our path, that, and basically the node we have on our short path. The fracture length is how the distance between one node and the other. Okay, and we need the length so that we can move with the same speed no matter how long is the lerp. We always want to keep moving on the same speed. Okay, the starting time and the updated position. This is for some easing in and out, but I didn't like the result. So, basically these are the variables we need to store if we want to keep lerping, to lerp our unit around and lerp it somewhat correctly. We could have make this the lerp between each point into a coroutine, but if we want to have interactions, interrupts, and overwatch that XCOM is pretty known about, okay, we need to be able to stop the unit exactly where the overwatch is triggered, and other stuff like this. Okay, and later on we're going to do a lot more stuff with the short path and the length of basically the length. We can check if we are closing in on a target. We can change the animation to make the character look like he's slowing down, or play a different animation that, you know, it's, anyway, we'll see it later. So we want to start lerping. We need to know the distance we are covering. This is our own delta we create. Okay, we take the time delta time and we subtract the start time. The start time we start lerping basically, and we multiply that by our moving speed. If the fracture length is equal to 0, then make it to be 0.1 so that we avoid an error. Fracture journey. We take the distance we covered and we subtract it from the fracture length, and that is why we need to check if the fracture length is 0, because you cannot subdivide by 0. Okay, if the fracture journey is greater than 1, that means we have reached to the end of the node, then update the position is false. So it comes over here, it checks this. If we have a new node to move to, okay, we do that. If not, that means we have moved on the path completely. The target position is the lerp we do from the start position, the target position based on the fracture journey. Okay, and then we need to handle the rotation. We find the direction, target position minus start position. We make the y 0, and if the vector 3, the direction, is not equals 0, then we make the quaternion, the loop rotation, and then we simply as lerp our transform rotation to the target rotation and all that by time dot delta time multiplied by the maximum speed we can move. Okay, or if you want to have a different rotation speed, you can do that too. And then the only thing left to do is get the position of our transform to be the target position. And that runs on update. Now on evaluate path, which is what we call after we have our current path, okay, we have each node we're going to pass, we need to evaluate it so it's kind of better. So we call the evaluate path from our player interaction script. We need to store our current direction. Of course, we will always start by 0. And then, for each node we have on the current path, we create a new direction, which is the current path we are minus 1. So that's why we start from the first, from the second node instead of the first one. So we create a new direction for the next node. Okay. And what actually this is let's make it so that it's a little bit more clearer. Okay, now it's a bit more readable. So we take the x of our previous node and we subtract it. We subtract from the previous node. We subtract the node we are currently at for both the x, the y, and the z, and that returns us. It's basically going to return a vector that's going to be from -1 to 1. So we need to check if the next direction is not equal as the current direction, and this is actually wrong. Now it's not exactly wrong, it's not exactly correct though. If we want to compare it, basically it's better to use the equals and all that stuff. Okay, so if the next direction is not equal to the current direction, then that means the direction changes. So we add the new node we are looking at, and we also want to add the previous one because the direction changes, so it's better to just make sure that we want to be on the previous. We want to take into account the previous node we were going to pass from. Okay, because there is no semi-directional movement. And if I uncomment this, you'll actually see it, what I mean. Okay, let's hit play. We have an extra unit over here that we do not need. Let's hit play. Let's assign the active unit. Okay, you see that there is a problem with this line, and basically because it's not the character cannot move over there. The way we want to move is diagonally at first, run a straight line over here and a straight line to the next node, and that's why we need to save the previous node to. Okay, then the current direction will be the next direction we just created, and we keep adding. We add the path to the short path. Okay, so let's continue. Reset moving variables. We simply need to reset that so that we can move the next time. If we move once on the path, if we want to move again, we simply reset the moving variables and we are moving without problems. So update position equals false, index path at 0, fracture length also at 0. And with that, pretty much I think we've covered most of it. Now have a few other scripts that we can check. Is the handle animation for the unit. Okay, namespace unit control. We basically need the animator and the stage. We initialize them. Set up animator. Okay, we have seen this multiple times. Get all the animators we have on the children and get the avatar from the first one, so it's easy to change models around. And then on update, set the float movement. The set float movement basically. If we are moving, set it to 1, or not, set it to 0, and then apply a dump time, and then time.delta time. Now the moving speed equals, we get that get movement. The moving speed, I think we use it on the lerp actually. We get the movement from the animator, so whatever it passes this, and we multiply it by the maximum speed we can move. And we do that because on unit controller, I think on update we were multiplying, but moving speed. So that basically, it makes it so that it appears like we have a bit of acceleration where we are starting moving. Okay, so it's not exactly the perfect solution over here, but it just it will have to do for now. Of course, we're going to see later a lot more stuff for this. IK handler is simply to make the character's weapon and okay, it's simply to make the hand of the character to grab the weapon on play. Okay, this model is from the ancestor. If you want, if you like, then go search for armored soldier. Okay, let me delete this one now. And I think we've covered everything we needed to cover for basically only this video though. And let's see if we have anything else on the Pathfinder. We have the Pathfinder master, and I don't think we've changed anything. We did not change anything over here. Okay, more info for this you will find on the previous on the pathfinding video, not the previous. Let's see the Pathfinder. The position. Now, I remember what we actually have changes, and we did a little bit of changes on the node script. Okay, namespace grid master as always, and where we were taking the world object, we also need a reference for the node reference. Okay, you probably get an error on the grid base because we were trying to assign on the node, you were trying to assign the node reference. Okay, you need to add that too. And I think we are complete for this part of the video. Now, this pretty much is the basics for... No, we're not complete. We need to actually see how we create the obstacles. Okay, so this is a wall. Let's take it out of here. Now, it doesn't matter if it's a wall or not. whatever it is, on the same game object that it has a box collider, we need a level object script. Okay, and I need to check if it's floor or obstacle or wall. We're not doing anything with wall, so if it's floor or obstacle. Okay, so wherever I put this, and let's not put it there because our unit initialized there, if I hit play, you will see that it both updates the tiles on the first floor, and because it reaches the upper floor too, then it updates the tiles on the upper floor. Okay, so for everything that it is, that it's going to be something that might block the movement of the player or everything else. Okay, it needs a collider and a level object script. Now for the floors, and I do not know where floor 1 collider, where for the second floors basically should probably be, I don't know where it should probably be. Obstacles, floor 2. Okay, for the second floor and only for the second floor, since it's only a few places where there is a collider. Okay, we have the box collider, level object to floor. Now, for the first floor, because we can pretty much move anywhere, I do not have different colliders. I only have one collider, which is floor 1 collider. Okay, I have one collider that covers the whole area. Now this isn't ideal, because if I had a lot more different levels and a lot more different objects and all that basically, that will mean that I will have to make I will have too many colliders, which I wouldn't know what to do with. Okay, so if you're going to see, we're going to see later on, and a lot later on, we're going to integrate the runtime level editor we did a couple of months back, or I think it was a month. Okay, and we're actually going to be based on how we put objects with that level editor. We're going to be changing the node preferences we have. So when we go and create the grid, we are not just using boxcast to check if we have other objects or if we have obstacles in our list. Okay, we're going to be using the stored level we have, and use all that to determine if the node is walkable or not, or if it's a special case. But that's not for, you do not have to worry about that for the moment being. We're going to do a lot of stuff with all this. Now, I think we have covered everything. So we saw how to make the obstacles. Okay, and now, even though we're going to do an XCOM style game first, we're going to be using this a lot more on different types of projects and on different types of turn-based. So this video works as the first for basically types of turn-based games you want to have, because we saw how we can move around on our Pathfinder. Okay, and you see that when I hit space, it runs no matter what. And we're also going to add later how we can get up on ledges, how we can pass a few walls. Okay, this shouldn't have made him move around. This should have made him jump over this wall and run straight. But we are going to see that later. So I'll end the video here since it's a pretty big one. And so, basically, don't forget to like, subscribe, share the video around. Okay, the more we grow the channel, the more cool stuff we can do. And consider also supporting me on Patreon, or if you want to jumpstart a project or a new game you're making, then take a look at my Gumroad page. You can have some project from the channel if you are new to this channel. Okay, so you can take one of those if you do not want to use Patreon. Okay, the references and scripts are already on those projects, and in turn you also helped me create more videos. Okay, all this stuff take time, and it's time it could have been used elsewise. Okay, and pretty much if I want to keep doing videos for this, then that means I can't be doing something else. So thanks for watching, and I'll see you next time.